In the previous video, we computed the integral of inverse sine x on the interval 0 to 1 by using integration by parts. But there's an alternative approach to this problem using trigonometric substitution. So the idea of the trig substitution approach is that we're going to let x be something that's easily undone by this inverse sine function. In other words, we're going to let x equal sine of theta. This means that dx is cosine theta d theta. And we'll go ahead and transform the limits of integration as we're working, so we can just move this entire integral to theta space. So we look at our substitution, x equals sine theta, and we say when x is equal to 0, that's our lower limit there. I have 0 equals sine theta. What must theta be? Well, the sine of theta is 0 when theta is equal to 0. We do the same thing for the upper limit. When x is 1, I get 1 equals sine theta. And the sine of theta is equal to 1 when theta is pi over 2. Okay, so this whole thing has been transformed to the integral from 0 to pi over 2. And then this inverse sine of x becomes the inverse sine of theta. And my dx was a cosine theta d theta. And so this inverse sine undoes the sine, and I end up with a factor of theta there. And this leaves me with a classic integration by parts integral, theta cosine theta d theta. For our integration by parts substitutions, we're going to let u equal theta, because when I differentiate that with respect to theta, I get something simpler. I just get 1. The other piece is going to be dv. All right, so we let u equal theta, and du is equal to d theta. We let dv equal cosine theta d theta. So v is just the antiderivative of cosine, which is sine theta. And we apply our integration by parts formula to transform this thing. So that starts out with u times v, or theta sine theta, evaluated from 0 to pi over 2, minus the integral from 0 to pi over 2 of v times du, or sine theta d theta. Now the antiderivative of the sine function is the negative of the cosine. Just to make things slightly more convenient here, I'm going to take this minus sign from out in front of the integral and move it inside so that the integrand is recognized as the derivative of the cosine function. Now before I write the next line, I'm going to go ahead and evaluate this first term across the limits of integration. When I sub in the upper limit there, I get pi over 2 times the sine of pi over 2. But the sine of pi over 2 is 1, so I end up with a pi over 2. And when I sub in the lower limit, I get 0 times 0, so that's just 0. Now as for this leftover integral, the antiderivative of negative sine is just cosine, so I have a plus cosine theta, and I'm evaluating that from 0 to pi over 2. When I sub in the upper limit, I get the cosine of pi over 2, which is 0, so that's gone. And then I subtract what I get from subbing in the lower limit. Well, the cosine of 0 is 1, so I end up with a pi over 2 minus 1. And this agrees with the previous answer we got, using integration by parts instead of a trig sub, so we're happy. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the ZaxLab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.